now we're going to be talking about some quadratic inequalities in one variable. And like I told you in the last video, what I mean when I say in one variable is that we won't have a y in the front anymore. Like we'll probably have like a number. So be like 5 is less than or equal to this quadratic. So x will be our only variable. And quadratic inequalities in one variable, they have solutions that can be graphed on a number line. And before we start graphing some on a number line, we need to talk about like what our solutions are going to look like and what they mean. So there's two different types of statements that you can find on a number line, and you guys have seen them both. And just like the inequality symbols, I want you guys to become fluent in these and what they mean and what they are saying. So we have and statements. And statements, I'll give you an example of one. Like 1 is less than x, which is less than 4. And now if you read this out loud, it actually makes sense. 1 is going to be less than x, and x is going to be less than 4. So it has to be a number between 1 and 4. And for these, like when we're talking about the solutions of our inequality, both conditions must be true. So, because this can be then, okay, sorry, back up a second. This can be broken up into two different inequalities, can't it? Because x is greater than 1 and x is less than 4. And so for this type of, for an and statement, both of these need to be true. It has to be greater than 1 and it has to be less than 4. And so our other type is going to be called an or statement. And I'll give you an example of one of those. So for these ones, it'll be x is everything less than 1 or x is everything greater than 5. It's just not those numbers. Our solution does not include the numbers between 1 and 5. And for this, at least only one of them, at least one of these has to be true. At least one of these statements here has to be true. So the reason that we need to know this, the reason need to know these and or statements is because we're going to be solving quadratic inequalities by using tables and using graphs. And
Alright, so we're going to be solving this. X squared plus 8x plus 20 is greater than or equal to 5. And we're going to do that using a graphing calculator. So I have my TI-84 over here. First thing I want to do is I want to graph each side of this inequality. And I am going to do it into two separate equations. And I want my y1 to equal to my quadratic and my y2 to be equal to 5. And so I'm going to go to y equals on my calculator. My y1, I want that to be equal to the quadratic. So I'll have x squared plus 8x plus 20. And then my y2, I'm going to hit the down button. My y2 is going to be equal to 5. And now we can graph that to see what it looks like. And so you can see there's my quadratic and there's my 5, my y equals 5. And now, so this is telling us that the x, like the solution to this is when our quadratic, this right here, is greater than or equal to 5. So everything up here, I know that this is going to be my solution set. And so now I want to, you're going to identify the values of x on the table where y1 is greater than or equal to 5. And what that means is, so I'm going to go second table, and here's my table. This is all my y1, y2, and x values here. And so I want to figure out where my x values, where y1 is greater than or equal to 5. So where y1 is greater than or equal to my y2. And I want to go down here. Okay, so you see this? All these numbers, I'm going to go back up here. All these numbers are all bigger than 5, right? And if I go all the way down here, all these numbers, they keep getting bigger than 5, and they just keep getting bigger and bigger. But right here, we're at negative 4, 4. 4 is smaller than 5, and I want to identify the values of x on the table where y1 is greater than or equal to. So this is the only one. And you notice that this 5, that's equal to 5, and then one below it, 5 is equal to 5. So this negative 5, 5, and this negative 3, 5, those are like kind of like my critical values. And so those are going to be two very important points there, because that is going to be where the parabola starts becoming greater than. And so what this is telling me is a parabola is greater to or equal to the line when x is less than or equal to negative 5. So when it's less than or equal to, so that's these negative numbers, because see, like negative 7 is less than negative 5. So when it's x is less than or equal to negative 5, and then when x is greater than or equal to negative 3. And so now we're going to want to know how do we write that as, what's our answer going to look like? I'm going to say that my parabola is greater than or equal to the line at x is less than or equal to negative 5, or, because it's an or statement, at x is greater than or equal to negative 3, and then I can graph it on my number line like so. I'm going to shade in negative 5 because it's equal to, I'm going to shade in negative 3 because it's equal to, and it's going to be everything greater than negative 3, and it's going to be everything less than negative 5. And now there is one of these to try on your own, but don't like fret too much, don't freak out, because we are going to definitely go over some ones on the calculator in class, because you guys are pretty new to the calculators. So